Hi everyone, and welcome to the first of 4 videos going through some past exam questions on ionisation energies. So this first question here has given us some ionisation energies of different elements, and the first thing we need to do is actually give a definition of the term first ionisation energy. Okay. So this is the energy required to remove one electron from each atom in 1 mole of gaseous atoms. And so it's another definition that we need to remember, but it's worth 3 marks, so that doesn't seem like a lot of work to do to get 3 marks. So you get 1 mark for saying the energy required to remove an electron. The second mark is for saying each atom in 1 mole, and then the third mark is for specifying that they have to be gaseous atoms. Okay. Right, and then this bit says, explain why the first ionisation energies show a general increase from lithium to neon. Okay, so this is going across a period. Okay, this is period 2 in the periodic table, and you can see that in general there's a general increase as you go across the period. Okay, there are some interesting things going on which we'll come across in later questions, but for here the general trend is just an increase. So we need to explain why that is. Okay, and for ionisation energies, there are 3 different factors that affect them. It's a 3-mark question here, so you can see what's going on here. We need to talk about each of them. So as we go across a period, the first thing is that the proton number is increasing. You have 1 extra proton every time, and so therefore it's going to attract the electrons a bit more strongly, and it's going to take more energy to remove the electron. Okay, so we can say that across the period, the nuclear charge increases. And the nuclear charge is just the number of protons, essentially. And we could also say that as you're going across the period, because you're adding electrons into the same shell, but the attraction to the nucleus is increasing because of the increase in the nuclear charge, it means that the atomic radius is going to decrease slightly. So if the atomic radius is decreasing, again, the electrons are going to be closer to the nucleus, they're going to be more attracted. So as you go across a period, the nuclear charge increases and the atomic radius decreases. So those are 2 of the 3 factors that affect ionisation energy. The third one is the electron shielding. So it's this idea that electrons in inner shells shield electrons in the outer shell from seeing the positive charge from the nucleus. Okay. As we go across a period, the shielding stays the same because you're adding electrons to the same shell. So that doesn't really make any difference. Okay, so we can put that in. Shielding stays the same. Overall, the nuclear attraction increases. Okay, so this means that the electrons are going to be more attracted to the nucleus. Okay. So it takes more energy to remove electrons. Or let's say to remove the outer electron. Because we're going to take out the outermost electron first. Okay. So those are your 3 things: nuclear charge, atomic radius, and shielding. The combination of those 3 things gives you the nuclear attraction. And it's the nuclear attraction that determines the ionisation energy. Okay, and then the next question following on from this then says, explain the difference between the first ionisation energies of lithium and sodium. So if we look here, lithium and sodium, so this is going across a period, and then we're back into group 1 of period 3. So lithium and sodium are both from group 1, and you can see that sodium's first ionisation energy is a bit lower than lithium's. So that's what it's asking us to explain here. Okay. So this we're now talking about going down a group. But we're going to talk about the same 3 factors that we just talked about. So let's talk about the nuclear charge. So down a group, the nuclear charge increases. Okay, because the further down the periodic table you go, the more protons you have. Okay. what else happens? As we're going down the group, we're adding an extra shell of electrons, aren't we? So the atomic radius is going to increase. And the shielding is going to increase because you've got a whole new shell of electrons in between the nucleus and the outer shell. So let's just think about what the overall effect of that is going to be. If the nuclear charge is higher, then that's going to attract the electrons more strongly. But if the radius is bigger, the electrons are further away from the nucleus. So then the attraction is going to be weaker. And if the shielding is higher, that's also going to weaken the attraction because you've got the other electrons in the way. So out of our three factors, two of them are making the attraction to the nucleus weaker, and only one is making it stronger. So overall, the nuclear attraction decreases. Okay. And this fits with the data that we see. If we go back, we said that sodium's ionization energy is a little bit lower than lithium's. So it's slightly easier to remove electrons from sodium because the nuclear attraction is decreased. Okay. Nuclear attraction decreases, so it takes less energy to remove the outer electron. Okay. So it then says here we've got the first ionization energy of oxygen and the second ionization energy of oxygen. Write an equation to represent the second ionization energy. Okay, so if we're doing the second ionization energy, it means we've already done the first ionization energy. So the oxygen is already going to be a positive ion. Okay, we've already removed one electron. Now this is a bit weird, seeing oxygen as a positive ion, but this isn't necessarily something that's going to happen in a reaction. Okay, it's just that's what the definition of ionization energy is, right? It's removing an electron. So if we're doing the second ionization energy, we're going to take our O+ and we're going to remove another electron from it to make O2+, and we need to show that electron that we've removed. Okay, and we need to include the state symbols. Remember our definition from earlier on, that it has to be in the gas form. Okay, and we don't put state symbols on electrons. It then says, suggest why the second ionization energy of oxygen has a greater value than the first ionization energy. Okay, and this is always the case. It's not something specific to oxygen. Second ionization energies are always, and don't use the word always very often in chemistry, but they are always bigger than the first ionization energy. Okay, and this is the idea that it's always going to be more difficult to remove the second electron. Okay, because what's going to happen is once you've taken the first electron away, you've then not got the same ratio between protons and electrons that you had before. So oxygen normally has 8 protons and 8 electrons. If I take an electron away, I've now got 8 protons attracting only 7 electrons. So they're all going to be attracted a little bit more. And in terms of the factors that we talked about, well, the nuclear charge hasn't changed, still 8 plus 8. The shielding hasn't changed because they're in the same shell. You could argue that removing one from that shell is going to reduce the shielding a little bit, but not really. I think the main factor we can talk about is the radius is going to decrease. Yeah, because if I've now got only 7 electrons being attracted by 8 protons, they're going to be attracted a bit more and they're going to shrink inwards a little bit. Okay, so we can say that the radius of O+ ions is smaller than the radius of oxygen atoms. And it's only 1 mark, so that's all we need to put. Okay, and then finally the last bit here says, explain the decrease in atomic radii across the period from sodium to chlorine. Okay, so we've got to explain why. We already mentioned this, didn't we, that as you go across a period, the atomic radius is going to decrease a little bit. So we just need to explain why that is the case. So the main reason is that as you go across the period, the nuclear charge is increasing. We're adding extra protons. Okay. So across the period, the nuclear charge increases. Okay. But electrons are being added to the same shell still, so there's not going to be any increase in shielding. Okay, we're still going to talk about the same factors that we always talk about here. Okay, it's just obviously we're not going to get a mark for mentioning the radius because that's what it's asking us to explain. But let's talk about nuclear charge. Now let's talk about shielding. Okay, nuclear charge increases, but the shielding stays the same. So this means that the nuclear attraction increases. Okay, we're not getting any extra shielding, and they're just being attracted more by the increase in the nuclear charge. Okay, so this means the nuclear attraction increases, and the electrons are pulled closer to the nucleus. Oh, my handwriting's going to bits. Closer to the nucleus, decreasing the atomic radius. Okay.